So we're going to proceed now with our program, and it's honored now to welcome to the stage Don Haas, who is the Director of Teacher Programs at the Paleontological Research Institution and its Museum of the Earth and Cayuga Nature Center in Ithaca, New York. Don's work in public outreach, teacher education, teacher professional development, and curriculum material development marries deep understandings of how people learn with deep understandings of the Earth system. He is past president of the National Association of Geoscience Teachers, a nationally regarded expert in climate and energy education, and he has led educator professional development programming throughout the United States. He is the co-author of books such as The Teacher-Friendly Guide to Climate Change, and he has served on the Earth and Space Science Design team for the National Research Council's, a framework for K-12 science education, practices, cross-cutting concepts, and core ideas. Don has taught at Colgate Cornell and Michigan State Universities, the University at Buffalo, Kalamazoo College, and Tapestry and Norwich High Schools in New York. So without further ado, please join me in welcoming Don Haas to the stage.
Thanks. Thank you. So we're going to start off with that question and just kind of plant the seed now. Here's the actual block of graphite, pure carbon, couldn't afford diamonds. Here is the Teacher-Friendly Guide to Climate Change, which I'll ask you folks to grab and pass around. And that was actually written with funding from a climatologist at Cornell and her National Science Foundation funded grant to study the carbon cycle, which we've been nicely talking about some this morning. And that was Natalie Mahalwald, and she is actually the lead writer of the 1.5 degree report from IPCC. She's a member of the IPCC. So speaking of carbon, this chunk has either 3 times as much carbon as in a gallon of gasoline, about the same amount as in a gallon of gasoline, or 1/3 of the amount in a gallon of gasoline. And I'll come back to that later, but think about what your answer to that question is. And I'm going to flip between a few different presentations and stitch together to make the hour. And we're going to start with It's Too Late, Let's Get to Work Anyway. I thought I had put a link in here to go to the other 2 parts, which are down here. The other 2, so this part I think will take about 10 minutes. This is actually the first time I've done this part in this way. And then Where Does Gasoline Go? We'll get you a little bit active in doing things with your balloons and your Post-it notes on your tables, so you won't be sitting the whole time. And that'll probably take 20 minutes or a half an hour. And then Fire and Brimstone in Fort McMurray will take another 15 minutes or so, and then I think we'll have some time for questions. So there's been a lot of discussion and warnings that if we don't do X by X year, we're going to be too late for various things. Well, the reality is we're already too late, and we need to get to work anyway. It's too late to prevent horrible consequences of climate change, and I'll also say I'm going to read mostly for this part, but in the middle part I won't do that. But when it's too late is when we generally get to work. We ended slavery too late. We stopped Hitler and his fascist allies too late. For millions of people in Europe and Americans as well and around the world. We got to work on civil rights and getting out of Vietnam too late. Being too late doesn't mean that it's too late to do something. It means we're already letting people suffer and die, but we can prevent some future suffering and death. Shit's getting real. The fires in the Amazon, California, Africa, and the Arctic bring to mind fire and brimstone, and we'll talk more about fire and brimstone in the course of the hour. This year's flooding on the Mississippi was also biblical in scale. I actually wrote this before the California fire season. European heat waves this summer were killers. I wrote this in August before Dorian had the most intense sustained winds of any hurricane on record, I believe. I think it was over 200-mile-an-hour sustained winds, which is just stunning to think about. And like I said, I wrote this before that happened. So somehow I had a hunch it might. It's also important to recognize that relying on K-12 education is too slow. If we rely on educating young people to address the climate emergency carried out in traditional ways, we'll be even more too late than we already are. So we must work in non-traditional ways. Some of that means helping our students to lead us. That means helping our students to be effective climate educators, communicators, and activists. They didn't make this mess, and they shouldn't be responsible for dealing with it, but there's really no choice. And we can help them lead government and corporate leadership to do what's right. And of course, Greta Thunberg is an inspiration. And very importantly, following up on the paradigms discussion of the last talk, she breaks all the rules of schooling. She's teaching us by not going to school. She sees her Asperger's as a feature, not a bug. At 16, she's taking a stand and getting global attention for it. Like Greta, we have to break the rules of schooling to make the kinds of change we need. If we wish for a society to continue to thrive, we must redesign education to actually improve things on a broad scale. It must be highly interdisciplinary, build understandings of both the nature of complex systems and how systems change. This is poorly matched, the highly disciplinary nature of K-16 education, especially grades 6 through 16. And this nice quote from Greta, "The eyes of all future generations are upon you," and by you she means me in part. "If you choose to fail us, I say we will never forgive you." We really ought to take those words to heart. Real problems are highly interdisciplinary. The issues that matter most in society, climate change, energy, water, soil, physical, mental health and healthcare, transportation, inequality, war and peace, agriculture, and our food system and human migration are all highly disciplinary in nature and can only be deeply understood from a systems perspective, and schools suck at that. Point blank. And a bald truth is that the critical thinking capabilities of the average American have not improved in decades, at least not in any conspicuous way, despite the fact that we spend billions of dollars trying to do that, to improve the outcomes of schooling. The critical thinking capabilities of the average American are not better in any conspicuous way. If educational innovations improved outcomes on a broad scale, we'd be able to tell. People would be smarter. People would not be doing a lot of the things that we are seeing on a national stage right now. The most important part of education, I believe, is preparing people to meet their civic responsibilities, which of course includes college and career, but it includes so much more than that. And to be clear, I am not speaking about test scores. There are challenges embedded in these statements. I challenge you to identify a way that the average American is better at critical thinking in a utilitarian way than they were 40 years ago, and to trace it to an innovation in education. I'm guessing you can't do that. If you can't come up with it that's both scaled up and improved outcomes, then work to change the system in big ways. That's a long-term thing, and we'll come back to long versus short-term things. Important to note, though, the educational system is not broken. That's the wrong metaphor. It's highly resilient and self-replicating. It survives like nobody's business. That's not the sign of an unhealthy system or a broken system. It's one that does something different from what we want it to do. Sweeping change in other systems, when we look across retail, communications, energy, transportation. When we look across other systems, we find that sweeping change involves more than fixing some piece of the system. It involves replacing infrastructure and or technology with infrastructure and or technology of a fundamentally different sort. Rewriting educational standards is akin to rewriting user manuals. We confuse that with rewriting operating systems. It is not the same thing at all. It's like if Steve Jobs or Bill Gates sat down and wrote a new book. Would they be billionaires? Would they have become billionaires? I don't think so. They did something very, very different from that. And I ask you to imagine what the world would be like if the education system changed as much in the next 25 years as the communication system has changed in the last 25 years. The world would be a very, very different place. Here's a 4,000-year-old classroom. It looks kind of like a modern classroom. Here's a beautiful meshing of a classroom from 1916 with one from 2016. And we could do the same sort of thing looking at a high school student or a college student's schedule. Virtually identical to not only 100 years ago, but probably 150 years ago. Even the course names would be the same. And the exam schedule and the semester schedule. That's all the same as it has been for 150 years or more. The oldest well-established standardized testing system, I think, in the world is the New York State Regents exam system. That was approved by the New York State Legislature in 1864, and the first exams were given in 1865, and my daughters in June of this year sat in a hot gym in June and did the same thing that people were doing 150 years ago. Where else do we do that in society? So while we've changed the way we put information on the front walls of classrooms, we no longer write on a rock with a different piece of rock. Almost everything else is the same as it has been for a very, very long time. And where else in society do we use the same basic technology of 4,000 years ago? So I've got two big asks. In the short term, we need to support the development of our students as climate educators, communicators and activists, and do so in as interdisciplinary and systems-oriented way as we can within the current educational system. And in the longer term, we need to change that educational system. So that's part one is done. And now we're going to switch back over to my chunk of graphite. And we're going to talk about some of the, that's some of the social science, sort of, and philosophy maybe. And now we're going to spend some time on the physical science, and then we'll get back into the humanities after that. So I'm still going to leave this hanging, but think about it. I won't pass this around because graphite's the key ingredient in pencil lead, so it does what pencil lead does. So now we're going to look at gasoline, and where does gasoline go, and my goals for the hour are first to astonish you, and maybe we've done that a tiny bit with what we just talked about. We'll do that some more in the next 20 minutes or so, and scare you, and we've had a lot of that this morning, and we don't want to leave it at that. We're going to close with giving you some hope and some motivation to act. So, looking at gasoline. Americans burn 391 million gallons of gasoline on the average day. That's more than a gallon per person per day. There are about 330 million Americans. And by the way, I will share all of the presentation resources so you don't have to take pictures unless you want to tweet them or something, which is great. So more than a gallon per person per day with 330 million Americans. That should give us pause. And now we're going to get a little bit active. I'm going to throw around some big numbers, and we need to think more carefully about big numbers than we generally do. So we're going to talk about scale for a moment. And in the back by the door there, you see that blue Post-it note by the two doors, blue Post-it notes by either doors. The one on the door that's open says 0 on it. The one on the door that's closed says 1 trillion on it. And you've got Post-it notes on your table, And I'm going to ask you to label, take 3 per person, and label them with 1,000, 1 million, and 1 billion. And then, as quickly as we can, place your Post-it notes between 0 over there and 1 trillion over there, where they go on the line. Does that make sense? Okay, so go back there and do your business with your Post-it notes. 1,000, 1 million, and 1 billion between 0 and 1 trillion. As quickly as you can. All right, there are a few people still back there, but I'm going to advance us along here. So there again is 0 and 1 trillion. And near 1 trillion, there aren't very many Post-it notes, but the rest of the way along that wall, about 30 feet, I measured it, the measure app on my iPhone this morning. It's about 30 feet between 0 and 1 trillion there. So 1 billion should be where? Pardon me? Pretty close to 0. About 1/3 of an inch away from 0. We should pause and think about that. And it's okay that you don't get that, but you need to start getting that, and you need to help your students get that. For up until the time roughly that I was born, almost no one needed to know the difference between 1,000, 1 million, 1 billion, and 1 trillion. Now we do. It's not in our evolutionary programming. Somebody who was driving a horse and cart across the plains of America or whatever 150 years ago really didn't need to know that at all. And in fact, most people didn't need to know that pretty much until right now. Certainly when we were coming out of Africa, nobody needed to know the difference between 1,000, 1 million, 1 billion, and 1 trillion. But now we really, really do. And we'll dig into why that is. You know, I'm starting with one of the reasons why that is to help us understand that idea of 391 million gallons of gasoline a day and 330 million Americans and 7.7 billion humans, something like that. Is that about right? Somewhere in that ballpark. And understanding what those numbers mean, it turns out it is really quite important for understanding climate change and lots of other things that actually matter a lot. Most controversial issues that we've dealt with, we find that understanding scale is a big piece of it. So everything goes in the first 1,000th of that distance because, well, we can all pretty much picture 1,000 reasonably well. My computer's probably worth about $1,000. You might work in a school that has 1,000 students, and 1 million is 1,000,000. And 1 billion is 1,000 million, and 1 trillion is 1,000 billion. So again, when we look across that 30-foot length there, it's about 1/3 of an inch to equal 1 billion. And you can see what we did. We were mostly off by a factor of many, many times. If you put 1 billion at 3 inches, you're off by 10 times. If you put it at 30 inches from 0, you're off by 100 times. And if we're making that scale of error routinely in our thinking, we need to get better. Like I said, hard to understand. A nice way of illustrating it is to think about seconds. 1,000 seconds is about 17 minutes. 1 million seconds is about 12 days. 1 billion seconds is about 32 years. And 1 trillion seconds is 32,000 years. And humans have been around for less than 10 trillion seconds. The Homo sapiens are somewhere on the order of somewhere between 200,000 and 300,000 years old. And the Earth is 4.5 billion years old. So that 32,000 years for 1 trillion seconds, that takes us to long before society and agriculture were established at any kind of scale anyway. So back to why we're thinking about big numbers. Americans burn 391 million gallons of gasoline a day. A gallon of gas weighs a little over 6 pounds. And I put a gallon jug that's a little more full than I intended because I didn't let Matthew know that I needed one that was 3/4 full. So I filled up my glass and we brought it down some. Gasoline has a density about 3/4 that of water. So if you've got a gallon jug that's 3/4 full of water, then that's going to give you the same heft in your hand as a gallon of gasoline would. That's going to be close enough. If you want to pour yourself out a little water into your glass, then we can bring it down to 3/4 of a gallon. And I want you to pass that around to get a feel for a gallon of gasoline. It weighs a little over 6 pounds. So that means that if you're burning 10 gallons of gasoline a week, then you're burning 60 pounds of gasoline, and somehow at the end of the week, there's nothing in your tank anymore, or 60 pounds is gone from your tank. We, of course, know that matter can neither be created nor destroyed, only what? Changed in form or metamorphosed or something like that. Middle school science there. In order to understand the transformations we're talking about, it's helpful to know what gasoline is. It's a complex mixture of hydrocarbons, and hydrocarbons are chemical compounds made out of hydrogen and carbon. On average, its chemical formula is something like C8H18. C8H18 has a name. Anybody know what that is? Octane. You see it on gas pumps all the time. And what do you get when you burn octane? Carbon dioxide and water, and energy, of course. And we're going to look at that in a cartoon scheme here. So here are some oxygen molecules or diatoms and an octane molecule. And we give it a spark, and things recombine. And this, by the way, is part of the reason that I'm using my own computer rather than one here, is because Apple's Keynote makes very nice animations pretty easily. Not so much on PowerPoint. So there's our spark, and we've gone we ended up now with carbon dioxide molecules and water molecules. And when we look at these 8 carbon dioxide molecules that we got from giving it that spark, we find that it weighs a bunch more than that octane molecule that we started with. And specifically, we can get into a little bit of the chemistry and say the molecular weight of carbon dioxide is 44 grams per mole. You multiply that by 8, you get 352. And the molecular weight of octane is 114. So the resulting carbon dioxide weighs more than the gasoline we started with. That's not magic. It's because the reaction used oxygen from the air and not just the gasoline. So burning this 6-pound gallon of gasoline yields 19 pounds of carbon dioxide for every one of those 391 million gallons that we burn every day, which is about 1/4 of US carbon emissions. So multiply these things by 4 if we want to think about total emissions. So here come the balloons. A gallon of gas is pretty easy to picture. It doesn't seem weird to think that it weighs about 6 pounds, and you've got a feel for that as it looks like my gallon jug has made it most of the way around. But 19 pounds is something that's invisible, and you can't smell it, you can't see it, and it's fine to breathe in as long as it's not bumping out the oxygen at a high enough rate to asphyxiate you. But thinking about that 19 pounds of an invisible gas is pretty hard to do. So we're going to think about it by using balloons, and I neglected to bring myself one up here. Thank you. And if there aren't enough on the tables, there's plenty more on the center table up here in front. So an inflated balloon weighs a little bit more than an empty one because the air and other gases inside it does weigh something. So we want to think about how many gallon-sized balloons it takes to hold 19 pounds of carbon dioxide. So we're doing this. Hold it empty. Think about how much it weighs now. And fill it up so it's about the size of that jug. So that's about the size of the jug. So you don't feel much of a difference in weight, right? But there is a difference in weight. And if you've got a sensitive enough scale, you can measure that. But it does weigh something more. So to help us think through this, and by the way, the strategy that I'm using now is called social mathematics, using approaches with concrete things you can get your hands on or see to help you understand really big or really small numbers. And I think that's a pretty important teaching strategy for bringing some messages home. So what are some things that weigh about 19 pounds? A fat cat. My larger cat's about 16 pounds. I have had one that weighed 19 pounds in the past. Small dog. A 1-year-old, 19 pound weights. A few gallons, 3 gallons of water is pretty close. Oh yeah, a barbell if you got a 20-pound barbell, or a 20-pound bag of charcoal or bag of rice or whatever. If you buy things in bulk, then you probably have 20-pound bags of something. So how many balloons is it going to take to hold? And again, subtracting the weight of the balloon itself and just thinking about the weight of the stuff inside it, how many balloons do you think it's going to take to hold 19 pounds of carbon dioxide? Lots and lots. 200? 300? A trillion? Not a trillion. It's about 1,100. About 1,100, yeah. So we've got about 50 people in the room, so each one of us would need to blow up something like 22 balloons in order to give us the volume of carbon dioxide and mass, roughly, although our breath isn't pure carbon dioxide, so it's not a perfect analogy. But we would each need to blow up about 22 balloons to get the volume of carbon dioxide gas that we get out of burning 1 gallon of gasoline. So there goes 100 balloons, so do that 10 more times, 200, 300, 400, 500, 600, 700, 800, 900, 1,000, 1,100. That's a lot of balloons from 1 gallon of gas. And you can also think about other aspects of that mathematics. So we get 19 pounds of CO2 that has a volume of 1,100 gallons, which you normally would convert to cubic feet or cubic centimeters or something. But wow, 391 million times a day we do that in the US for numbers for 2017. That's over 7 billion pounds of CO2 produced every day just from burning gasoline. Multiply it again roughly by 4 to scale it up to total US emissions. And US emissions are now, I think, on the order of 15% of global emissions. So you can do the math from there. Yeah. Not yet. Hopefully they will. It's complicated, of course. If you get your electricity from coal, that's not very helpful. And in Illinois, do you know where the biggest source of what energy source is the largest for the state of Illinois for generating electricity?
Nuclear.
Yeah, it's nuclear. That makes Illinois pretty unusual. Most states that's not true for. I believe Illinois is the largest generator of nuclear power in the country.
What about the Trump administration lowering the standards on coal, on fuel?
Well, as it turns out, coal companies are going, there was just a bankruptcy for Murray Energy, just declared bankruptcy 2 weeks ago or a week ago. Regulating it at this point in time, or deregulating it, I should say, isn't having that much of an effect.
Because the auto industry, where the standards which Obama got that are being thrown out, that will be catastrophic.
Yes, that is not a good thing. We'll come back to that, I think, but for the sake of time, I'm going to shoot along. And I spilled my beans here. So if a gallon of gasoline is about 87% by weight, how does this compare to the amount of carbon in a gallon of gasoline? What do you think? I gave you three choices at the beginning. You remember what they were? So is this 3 times as much carbon, about the same amount of carbon, or a third of the amount of carbon in a gallon of gasoline? It's about a third. It's about a third. And that's because I made a mistake, which I'll talk about in a moment. So there's 5.5 pounds of carbon in a gallon of gas. Wow, that's a lot for 391 million times a day. And I goofed here. So I ordered a 2 by 2 by 6 inch block. I actually meant to order a 6 by 6 by 2 inch block. So it should look like that. For every single one of those 391 million gallons of gasoline, there's 3 times this much carbon in it. Every day, 391 million times. So 3 times was the right answer. Or 3 times the mass of this is the right answer. So if you want to take that carbon back out of the atmosphere, first off, the simplest thing to do technologically is to not put it there in the first place. And we don't talk about that nearly enough. We talk a lot about where our energy comes from when we talk about energy and climate. And I'll also throw out one of my favorite quotes on energy and climate from Chris Hayes, who says that talking about climate without talking about energy is like talking about lung cancer without talking about smoking. Our climate problem is almost exclusively because of the way we get and use energy. So we need to think very, very carefully about that. And the only truly environmentally friendly energy source is the one you don't use. When we talk an awful lot about what kind of energy we use, we don't talk nearly enough about how much energy we use. And I'm pretty certain that the real breakthroughs are going to come through ways that we figure out how to use less energy. And some of that is incredibly technologically simple. Ride your bike. Don't live 50 miles from work. Things like that are a big piece of it. And that's, but we'll come back to that too. So, but if we do put it into the air, the simplest thing to do technologically to take it back out of the air is to plant trees. Wood's about half carbon, 45 to 50% carbon. So if 5.5 pounds of carbon goes into the air from burning each gallon of gasoline, how much wood do we need to go? We'll make the math simple and say that wood's half carbon. How much wood do we need to grow to take that carbon back out of the air? Roughly 11 pounds. So 5.5 pounds, 50% of the wood is carbon, so that'd be 11 pounds. So that's to sequester each gallon of gasoline we burn. That's a lot of wood per gallon. And we can't let that burn or decay, so we have to put it someplace where it stays forever and ever, or figure out a way to be neutral on that. And it just so happens that this weighs 11 pounds. So, next time you fill up your tank, as you watch the gallons go by, say to yourself, 2 by 4, 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 2 by 4. However many gallons it takes to fill your tank, that's how many 2 by 4s you need to plant to grow, and not just plant, but to grow to offset each one of those gallons of gasoline. I will get to the hopeful part. not there yet. I'm hoping I've astonished you by now and maybe scared you a little. 390 million times 2x4s a day means 4.3 billion pounds of wood grown every day. Are we doing that now? No. That's more than 1.5 trillion pounds of wood a year. We need to, I believe it's roughly triple the amount of forested land in the US. The US is about 25% forested, and we need to go to about 75% forested to take out the carbon that we're putting in every year. That doesn't account for the carbon that we've added over the time period since the Industrial Revolution, almost the vast majority of which has been put in the last 50 years or so. And we can look at the stuff for coal and things too, but I'm gonna change gears again and go to part 3 and talk about fire and brimstone and Fort McMurray. The subtitle is important. Did I ask how many English teachers we have? How many English teachers do we have? Just a few. Sitting on my table is another book underneath the paper, I think. I'm gonna hold that up, and I forget the exact title. Can you read that?
Climate change to adolescents.
And the subtitle?
Reading, writing, and making a difference.
So that was jointly published by Routledge Press and the National Council of Teachers of English, who approved a position statement earlier this year on teaching climate change in the English class. And the National Council for the Social Studies also, they haven't passed a position statement yet, but I hope at some point they'll start thinking about that. But they do have some resources out there. And the National Congress for, what's it called? Human Ecology, used to be HOMEC, is on sustainability next year in Atlanta. So we can do this across the curriculum. It's better if we think about how to connect to one another, but it's nice that there are resources out there across the curriculum. This is drawing almost directly from the Teacher-Friendly Guide to Climate Change, which, I should say, is full text free online at that first link, I believe is the right link. There's a different link that I use more now. I need to update that. But I'm pretty sure that'll get you there. Again, I'll share links at the end that'll definitely get you there. It was written with funding from the National Science Foundation, so we're able to make it free. And the book from the Heartland Institute was mentioned earlier today. Heartland Institute being the world's largest climate denial organization. How many of you got the book from them that's got a lie for a title? Why Scientists Disagree About Climate Change? Anybody in here get that? Just one or two? They sent it to 200,000 science teachers just as we were about to go to press with this book. And we said, oh, our chapters were all laid out, and it was literally, I think, 2 weeks before we were going to go to press, and that hit the news. And we said, well, we need to do something, but we're not going to go back and redo the page layouts and so forth. So we added an FAQ chapter that addresses some of the things in the Heartland Institute book. And we said, if the Heartland Institute is going to send their propaganda book to science teachers across the country, we're going to give those teachers a good resource as best we can. And we said, we're going to do a crowdfunding campaign. And so far, we haven't gotten to Illinois yet, but we've raised enough money to send it to every public high school in 14 states. And some red states. And our largest contribution came from a conservative organization that wishes to remain anonymous because they accept climate change. And they gave us funding for 6 of those states. So not every conservative is wrong about climate change, just their leadership. And I'm going to fly by this. I'm not going to fly by that. I'm going to pause here and deputize you all as climate change communicators and invite you to do the same with your students. That An interesting study came out earlier this year that showed that kids are pretty good at teaching their parents about climate change, and probably many of you won't be surprised that girls are better at it than boys. And if you Google something along those lines, you'll find it pretty quickly. It's pretty interesting. But you should deputize your students as climate change communicators and get them thinking about it. Okay, now we're going to talk about fire and brimstone. What does fire and brimstone bring to mind? Hell and damnation, maybe hell on earth. And think about how it informs the way you see the world and how it informs the way people who don't see the world the way you do see the world, including maybe some of your students. Quoting from the King James Version of the Bible, in Revelation, and the devil that deceived them was cast into the lake of fire and brimstone where the beast and the false prophet are, and shall be tormented day and night forever and ever. And there's a picture of a 400-year-old picture or something like that of what medieval artists thought fire and brimstone looked like. And here is a different look at it.
Biblical.
What he means is Old Testament, Mr.
Yes.
Mayor. Real wrath of God type stuff.
Exactly.
Fire and brimstone coming down from the skies. Rivers and seas boiling.
40 years of darkness, earthquakes, volcanoes.
The dead rising from the grave.
Human sacrifice, dogs and cats living together, mass hysteria.
Enough, I get the point.
So, when I saw Fort McMurray's fires in 2016, I thought of fire and brimstone. Do any of you remember the fires in Fort McMurray in Alberta, Canada in 2016? Yeah, so there you go. So looking at just a little bit of that, and I muted this one so we don't need sound on this. And this video actually came out during the evacuations. They ended up evacuating 90,000 people, which is less than half of what was evacuated in California earlier this month, or last month. But the biggest evacuation in Canadian history, the most expensive disaster in Canadian history, and stunning. Started with forest fires burning in the Canadian Rockies in April. It is freakish that forest fires of substantial size were burning in April in the Canadian Rockies and burned it through May and into June and maybe even into July. It was horrible. And those poor folks in Fort McMurray. It's interesting too, and we'll come to that in a moment. And thinking about apocalyptic rhetoric, we use it a lot. And some of our favorite stories use apocalyptic rhetoric. Or some of our most told stories use apocalyptic rhetoric, like the Lorax. Although this quote is not actually from the Lorax's mouth, but from the Oncelers, who said, unless someone like you cares a whole awful lot, nothing's going to get better. It's not. That was a pretty apocalyptic ending to that book. And we've been telling apocalyptic stories as long as we've been telling stories. When we gathered around the fire, some of those campfires 200,000 years ago were surely apocalyptic ones. And we use that kind of language when we talk about polarizing issues pretty regularly. And people at both poles in the climate debate talk about different kinds of apocalypses, either destruction of the environment or destruction of the economy, bringing down the American way of life or society or whatever. And I don't think we're using those very, very thoughtfully an awful lot of the time. And my goal here is to help us think about it more carefully. So recognizing some of the structure, apocalyptic stories involve prophecies. Prophecies are predictions. And while it's difficult to link specific events to climate change, the drought that led to the fires in Fort McMurray aligns very much with what climate scientists predicted. We're too late, let's get to work anyway. I wrote that before, as I noted, before Dorian had the highest sustained winds of any hurricane in recorded history. because I knew what climate scientists were predicting, and a couple of weeks after I wrote it, it came true. I'm not calling myself a prophet. I'm saying that maybe is the case for climate scientists. But prophecies are more than predictions. So who's got a good religious literacy? What else are prophecies besides predictions? My grandfather was a preacher. So prophecies also call for you to change your ways. They have a moral element to them. They ask you to repent, not simply to apologize, but to behave in a fundamentally different way than what you were doing before. And in a pretty meaningful way, climate scientists are doing that too. And here is Fort McMurray, prior to the fires, in Google Earth. What's the big industry in Fort McMurray? No, but you're close. Tar sands or oil sands. Tar sands and oil sands are essentially synonymous. So it's energy industry, but it's not hydrofracking. It's refining, it's extracting and refining tar sands or oil sands, which is kind of like asphalt, but naturally occurring. And you turn that into oil in a pretty intensive way, energy intensive way, and therefore climate change intensive way of producing a barrel of oil. And they've been doing that for a long time, and it's huge. Here's the 20-mile scale bar. So that is a gigantic operation, one of the largest such operations in the world. And when we zoom in, an interesting thing there is there's these yellow pyramids, which again are huge. There's the 2,000-foot scale bar. So this is like 1,500 feet across, or on the order of a quarter of a mile or something like that. And there are 3 of them. They are stories tall. This is the trailer of a tractor trailer. What is that yellow stuff? It's a byproduct of refining. Yeah, it's a byproduct of refining the tar sands or the oil sands. Pardon me? No. It is sulfur. What's an archaic name for sulfur? Brimstone. Because it forms on the brim of volcanoes. So sulfur forms on the brim of some volcanoes, so therefore it's brimstone. And it is something that they're producing way more than they can sell in Fort McMurray. And if you've ever been to Vancouver, you may have seen huge piles of sulfur there too, because what they can sell, they run by rail over to wherever I just said, and sell it. Now, Fort McMurray was but one recent disaster of biblical proportions. So Baton Rouge in 2016 had some pretty impressive floods. 2017 hurricane season, in this picture there are 3 hurricanes on screen there. Buffalo's knife storm in November of a couple years ago. This is the city of Buffalo. This is the wall of lake effect clouds. And this is someone's door to the outside, open to the snow packed up against it. And it was called the knife storm because it formed a thin blade. Where I live in Amherst, New York, we got about 2 feet. 10 miles to the south of me in Lancaster and West Seneca, they got 7 feet in the course of 4 days or something like that. It was actually 2 storms on top of one another. And 10 miles north of me, where my mom lived, they got about 6 inches, and 10 miles north of that, they got nothing. So very weird lake effect snow. Lake effect snow is changing to some degree in the climate change world. And of course, California's 2017, 2018, 2019 fire seasons. I've added a year to that list each of the last 3 years since I first gave this presentation. And that's not, however, to say that oil equals evil. And that's also a really quite important idea. Everything that we can see right now is here in some meaningful way because of fossil fuels. If one of you keeled over right now and we needed an ambulance, we would be very, very glad for fossil fuels. And I think it's really important to remember that. Fossil fuels are almost magical. They made our modern way of life possible in a huge variety of ways. At the same time, they endanger our modern way of life. And I think it's really unfortunate that we don't talk about both of those things in the same conversation very much at all. They're both true, and we should acknowledge both of those truths. Moving along, there are at least 5 reasons for exploring our use of this kind of rhetoric. One is that the kind of story is very commonly used, and I don't think we pay enough attention to that, so I think we'll do better if we pay more attention. Such approaches have substantially different outcomes for people in the same audience, so you'll motivate some folks to work with you, some will simply tune it out, and others will actually be motivated to work against your goals. And it's really important to recognize that if you've got more than 2 students in your class, you've got more than one audience. And they will respond differently to whatever it is you do with them. It's a good opportunity for making interdisciplinary connections. It's a good opportunity for building understanding and appreciation of complexity, and it's good to help us identify problematic claims. If an argument is grounded in a Paradise Past narrative, once upon a time everything was rosy, make America great again, or it promises a simple cure for multiple problems, or if it's grounded in a narrative of good and evil, be suspicious. It might be right, but those are mythical structures that often are not really grounded in what's going on. Some bottom lines: use apocalyptic framing very carefully or not at all. But moral framing is still important, and we're going to spend our last few minutes looking at that. So shifting gears once again, the end of the world has been prophesized for a very, very long time, but hasn't come to pass yet. That should give us some hope. We've always been wrong about the end of the world, at least at a global scale. It's important to note that at regional scales, there have been apocalypses. And we live in wonderful, horrible times. So now I'm going to go back to reading a little bit more, again, pretty much directly from the book. So, teaching about climate change can be horribly depressing work. It seems as though we are marching headlong into hellish times and are not sufficiently rising to the challenge. This, to some degree, is the natural state of things. We have always lived in horrible times, if you look at it that way, which I tend to do, although since I've gotten divorced, it's been better. We've also always lived in marvelous times. Sometimes I can see that too, but reminders are helpful. When the situation becomes dire, as it seems to be doing now, we do have a history of rising to meet those ominous challenges. It is my hope that we are in the process of doing that now. As you mentioned, I think we're coming up on a tipping point. I'm been more optimistic about this in 2019 than I have been for a while. To consider the concept of wonderful, horrible times, I'm going to quickly step through 5 generations of my own family history. It's not the idea that you tell my family history, but use this as a model for thinking about something you might do. My great-grandfather, Adgett Loomis, was born in 1843 in Connecticut, and my great-grandmother, his wife, Minnie, was born in 1847 in Ohio. Slavery was still firmly entrenched in the American South, and Adgett and his brother Lucius both fought for the Union Army, and Lucius died at the Andersonville prison camp. Clearly, these were horrible times. And there is my great-grandfather in his Union Army uniform, and my great-great-uncle, Lucius. The Civil War ended, and my great-grandfather marched in front of President Lincoln, and I like to pause and mention that my mom knew her grandfather, and my aunt, who is still around, and their cousin, who is still around, knew my great-grandfather, who marched in front of Abraham Lincoln, which makes it so I'm 2 degrees of separation from somebody who marched in front of Abraham Lincoln, and now you're 3 degrees of separation from somebody who marched in front of Abraham Lincoln. It really wasn't that long ago. Horrible times were not over, but the abomination that was slavery did come to an end. Adgett and Minnie married in 1871 and honeymooned in Niagara Falls. They went on to have 5 daughters and 4 sons, and were married for more than 50 years. That's how my mom got to know them. The brood included twins, Ruth and Ralph, born in 1891. Ralph was my grandfather. I don't know if his life or their life was wonderful, but it did have some wonderful outcomes. And there are my grandparents on their great-grandparents on their honeymoon. Cross your eyes, you can see it in 3D. Virtual reality's been around for a while. My grandfather also saw the tragedy of war, serving in a machine gunner's unit in World War I. He also saw pestilence, helping to manage an impromptu hospital during the Spanish flu epidemic. His twin, Ruth, died as a young woman, probably suicide. But as these horrible things were going on, wonderful things were happening too. Nellie Brown, my grandmother, was one of the only women in the University of Missouri's Rocky Mountain Geologic Field Camp, and Grandpa went on to earn a master's degree in agricultural economics and then a divinity degree. As an extension agent, he was effective in helping bring an end to swine cholera. He married Nellie, and they had 4 children, including twins of their own, Carolyn and Marilyn, my mother, who were born in 1931, and my grandparents were married for more than 50 years. Grandpa managed a dairy co-op and preached in several churches and returned to agricultural extension work for the University of Missouri in 1936, and Grandma taught physical geography and more. And there's my mom and her twin, and there's Adolf Hitler. And Hitler rose to power in Europe, and the Japanese bombed Pearl Harbor, bringing the US into World War II, and my grandfather was fired from the extension as, quote, the extension didn't need any pacifists, remembering that he came by that honestly as a machine gunner in World War I. A few years later, my father, Roger, enlisted in the Navy. Though fortunately the war was in its last year, he actually finished, he was actually in Chicago at the Navy Pier at the end of World War II. These were horrible times, but the war ended, and my dad served until just before the Korean War began. My folks met at the University of Missouri, Dad attending on the GI Bill, and there's Cleveland's Cuyahoga River on fire again. It burned multiple times. It wasn't so long ago. We're progressing to the now. And Jim Crow was still festering in the South, and Joe McCarthy was feeding the Red Scare, and rock and roll was coming up, and life expectancy was growing, and the skies were black with smoke and smog, and rivers caught fire, and my parents married and had 6 kids, beginning with, beginning with my brother in 1952 and ending with me in 1963, just a few months before Kennedy was killed. And Dad worked on technologies to see people through the forests of Southeast Asia, and my brothers worried about but were not called for the draft. And Mom was a university librarian who wrote books about books, and Martin Luther King Jr. and Bobby Kennedy were killed in riots. And there was Woodstock and the Civil Rights Act and the Environmental Protection Agencies. They were wonderful, horrible times, and Mom and Dad were married for more than 50 years. And there's us. I'm the cute one. And Richard Nixon and Kent State and free love and disco and the lakes and rivers got cleaner and the bald eagle came back. And eventually I got married and had 2 wonderful kids. Kiana born in 2001, just a few months before September 11th, and Nellie in 2004 as the country grew more and more mired in America's longest war. And there's the Village People. All along, we worried about the fate of our children in these turbulent times, whatever time it happened to be. All along, horrible things were happening that looked like the end of the world. And each time it looked like the end of the world, we did things to make it not be the end of the world. And okay, it never really looked like the end of the world, though it may have looked like the end of civilization. That doesn't need saving. This might. Most people are beautiful. Yes, horrible things are happening now. This was largely written in July of 2016 in the aftermath of a series of horrible shootings, and it looks to be an unending series of horrible shootings. But violent crime is actually at its lowest level in decades, which is pretty wonderful. And 2016 went down as the hottest year on record, which brought unprecedented droughts and floods and fires to various parts of the world, which is pretty horrible. And my daughters are kind. Excuse me. Hardworking, smart, happy, engaged in things that make the world a better place, and beautiful. And hopefully your kids are too, and so are you. And there's 2016, which was the hottest year on record. 2018 was the 4th hottest, behind 2017 and 2015. 2019 is on track to be in that top 4. Last month was the hottest October on record globally, and it was the 4th month this year that was true. There are horrible things happening in the world right now. when the horror becomes clear to enough people, we do something about it to make it less horrible. Let's do that now and celebrate the wonderful things too. So I'll stop there. Thank you. I don't know how much time we have. Okay, we have some time for questions.
Thank you for your presentation. I have an impression about when we are talking about a climate change, we're always addressing something horrible in our Earth. But I mean, I'm just talking.
We always address what?
About horrible world.
Yeah.
The world is horrible.
Yeah.
We are facing a lot of problem nowadays. Mm-hmm. But when I intended today, I just know, do you have a conference here? And I just came in anyway. Mm-hmm. So, but my question is only one thing. I like to, you maybe can direct me the direction. Mm-hmm. Any kind of report or any kind of books or anywhere website I could look at, more like why we need to care about climate change so that we make our world better. I just want to see the positive side. Rather than, to me, it sounds like a more religious, I'm teaching religion, basically. Mm-hmm. Religious ideology to make you fear, to make you anger, make you feel you are living in a horrible time. But can you, any even scientific fact, tell us when that climate change happened to us, when even if we can prevent that, what it makes it better? Given that we're not living in Amazon, but I totally really respect the people living in Amazon and indigenous people. Now say that we're living in America.
Well,
so I mean, I'm sorry, maybe my question doesn't make sense, but I'd really like to know that. Thank you. Yeah.
Certainly for the folks in California who have seen these horrible fire seasons year after year, it's pretty blatantly horrible. The hurricanes, while we can't point to, we can't look at a hurricane typically and say this was caused by climate change. That is called attribution science, and it's getting better and better from year to year. But one thing that, a nice analogy for thinking about that is when we looked at Barry Bonds and A-Rod hitting home runs, we couldn't look at a home run and say, he hit that one because of his steroid use. But we could say that he was much more likely to hit a home run because of the steroid use. So the atmosphere is effectively on steroids. And it is changing everywhere around the globe in various ways. I recently heard a thing that may be more applicable to Buffalo and Chicago than other places in the country, but the Farmer's Almanac, which I don't know about how accurate their predictions are, but they say expect this coming winter to be a polar coaster, which I like that label. And we've seen that some places are getting hotter, some places are getting colder in ways that are messing things up. And I think one of the most important things to think about when thinking about climate change that we don't talk about all that much is that farming depends on a fairly stable climate. And the climate is changing in lots and lots of places. And that's having substantial effects for anyone who eats. And I'm pretty sure that's all of us. Chances are actually decent that Chicago and Buffalo will fare okay in the climate change regime. And my crystal ball, which I don't know how much you should trust my crystal ball, but my crystal ball says that shrinking Rust Belt cities are going to see a reversal of their population trends because we're overbuilt in terms of infrastructure and we've got good fresh water. So I think we'll see people coming back up here, which will tax a lot of systems in a lot of ways and buy real estate in the Rust Belt. Yes.
So as a former resident of Miami, I went through several hurricanes. Have other scientists tried to explain the 2005 hurricane season when the number of hurricanes was so big, they had to go into the Greek letters after the alphabet.
Yeah. Well, climate trends are looked at on a 30-year time scale. 2005, we were already seeing the effects. They're more pronounced now than they were then, but they were already rolling along. It's another interesting piece that's kind of the same vein is that I think it was 2017 when Australia had to add a color to their National Weather Service maps for being over 35 degrees Fahrenheit, or Celsius, I mean. So like 120 degrees. I'm not as adept at that translation as I should be. But they got days so hot that the weather maps that they had been making for a very long time didn't accommodate that. These changes are real and happening now and affecting real people that we know. I have a friend whose parents lost their house in one of the California fires last year, not this year. And Hurricane Sandy hit an awful lot of people I know across like 7 states.
Hi, thanks again for that presentation. I just had a quick question. I'm a foreign language teacher, I teach French, and we're talking about sustainable energy and green energy. And the reason why I distinguish between the two is that in our readings, we have that, we discovered that green energy is not necessarily sustainable in comparison to the demands of energy that we have in our society, and that's produced by nuclear reactors and so forth. And so we're learning about eco-communities such as like BedZ outside of London and so forth, where they're sort of self-sufficient communities, solar panels and stuff. And then of course there's the Green New Deal and ways of promoting more green energy. But how do we teach the students that green energy can work? And in cases like, our dependence on, high dependence on energy and our need for nuclear energy can be also balanced with green energy or so forth. I don't know how would it go about that.
There's an awful lot to that question that I could spend the rest of the afternoon on. It is very, very complex with, again, a simple bottom line that the only truly environmentally friendly energy is the energy you don't use. But the coal is no longer practical. For no one's building coal plants in the United States, and the orders for coal plants in China and India and so forth are falling off, and several coal-powered large coal energy developments around the world have been canceled because it doesn't make economic sense anymore because solar and wind have come down so much in price. Let me see if I've actually got this open. Not that one. Yes, yeah, and another mentioning Saudi Arabia reminds me of. I have too many tabs open, in case you're wondering. One of my favorite lines is from a Saudi oil minister in. I don't see it. Oh, there it is, very bottom one. In the 1970s said, the Stone Age didn't end because we ran out of stones. The oil age is not going to end because we run out of oil. We have gotten increasingly more skilled at getting hard-to-get oil out of the ground. We are just not going to run out. If we do, we're terribly, terribly screwed in other ways. We're changing our energy system incredibly rapidly. We now get more electricity from natural gas than from coal. That change happened a couple of years ago. Texas is now the biggest producer of wind energy in terms of number of kilowatts. New York, by the end of 2020, will get 0% of its electricity from coal. We're under 1% now. And it was 3 or 4 years ago that we started getting more electricity from wind in New York State than from coal. One of my favorite political cartoons is from 1860-something, I forget the exact date, where it's a drawing of a bunch of whales having a fancy ball, and the caption is, "The whales celebrate the discovery of the oil wells in Pennsylvania." We have seen that over and over and over again, where we we find an energy source that's easy to get until we use most of it up, or the easy to get stores of it up. And then we go after something else. We've seen that happen all over the globe, all throughout Earth history, or all throughout human history, I should say. Holland rose to be a world power because they figured out what to do with peat, to burn it, to get energy. And that created the tulip boom because they became wealthy enough to spend as much on a tulip as on a house. And that didn't last terribly long. While they were getting the peat out of the ground, they used up the stuff that was easy to get and went after things that were harder and harder to get, more and more expensive to get, more and more environmentally damaging to get. Well, over in Great Britain, they were getting coal out of the ground and repeating that over and over and over again. And in the eastern seaboard of the US, we cut down all the trees 100 years ago or 150 years ago to use mostly for fuel, also for building, and so on. So that's a story that plays out over and over again throughout our history.